Let's walk through modeling a timber frame, E16 junction. We will start this model in free model and build up each layer of the wall individually. You can use the right-hand editor or drag your material layer to get the correct dimensions. Use your mouse wheel to zoom in and out of the model. We have a clone layer feature, which allows you to click on a layer and clone the layer dimensions. These can be added to any side of your layer. This allows you to quickly create an adjacent layer, which can then be changed to the correct material. This is especially helpful when creating a wall model, for example. You will see as the wall build-up is added when dragging the layer exactly into position, you get a blue X to confirm the layer is snapped into position. Let's continue adding the wall layers from the insulation layers through to the plasterboard. We will use the Add Layer to the Right feature to quickly build up this wall. You may find it useful on thinner layers such as plasterboard to zoom into your model to help with accuracy. As this is an E16 corner junction, now we have modelled one wall, we need to also add the adjacent wall on the corner. You can drag your layers into position. We will amend for the correct modelled length of the flanking elements when complete. In AutoPSI, we only model the layers shown at the front of the model, so don't worry about any material overlap. We are using the clone material feature to create the layers from the original wall and resizing them in our model. Let's continue this process until our model is complete. We now have our base geometry complete. Click through your layers to ensure your thicknesses are correct. Now we need to consider the effective length of our model, ensuring it is the greater of 3 times thickness or 1 meter. We can check out thickness by using our U-value tool. For this model, you can see our modelled length should be 1128 millimeters. Let's use our guidelines feature to ensure the correct extent of our model. You can click to create vertical or horizontal guidelines and then create an offset line to ensure modelling accuracy. Now, right-click and drag to highlight your entire model. Once this is done, you can drag to extend your model. Holding down Shift will ensure the thicknesses do not change. This ensures the extent of our model is accurate. Let's repeat the process with our other wall. Now you have an accurate effective length for your model calculation. You can choose to keep the grid lines or delete them now. Let's now add the bridging elements to our model. Remember, only non-recurring bridges are added for your PSI-value calculation. Bridges can be created from the left-hand menu and dragged into position. Remember to zoom in if you need to for accuracy. You can clone bridges in the same way you can layers. We have a range of standard bridge shapes. However, these can be easily edited. Now let's add our boundary conditions. You can click around the model to add the applicable boundary conditions. Right-clicking can toggle between external, internal, and adiabatic boundaries. Now the boundary conditions are complete. The final step is to add your U values. Click to add U values and drag them into position. Remember to adjust the U value effective length to the correct length for the model. For an E16, this requires U values on both walls. Now your model is complete. You can click Calculate to get your PSI value. You can now download your full PDF and save your junction to your library.